So now that we've figured out Earth's layers, the next step in our Earth science journey is learning about Earth's plates. And before we start talking about anything, we always talk about vocab. So that's what we're going to do today. Earth's plates vocabulary. The first word we have to talk about is tectonic plates. And I think you guys have heard this before. If you haven't, that's okay. A tectonic plate or the tectonic plates are huge pieces of the crust and uppermost mantle. We know already this is the lithosphere because we just talked about all the layers of Earth. Anyway, these plates float on top of the asthenosphere. We know that layer is the one right below the lithosphere. So there are 7 major tectonic plates that we're going to talk about. There's a bunch of little ones, but we're not going to worry about those. The 7 major ones are the North American plate, and that one is right up here. Okay, the North American plate. This is the one that we live on. The next one is the South American plate, and you'll see that one right over here, the South American plate. Next, we have the Eurasian plate, and you can see, the Earth is round, right? We can't make a round picture on a flat PowerPoint, so this is just a flat map of the United States, and you see Eurasian plate is way over here, but it also is over here, okay? And that's because this is a flat map. We can't make a round picture on a flat PowerPoint, okay? That's the same plate, it just wraps around. Next, we have the Pacific plate, and the Pacific plate is the one all the way over here under the Pacific Ocean, okay? Pacific plate, Pacific Ocean should be easy for you to remember. The next one's the African plate, and the African plate is going to be, that's right, under Africa. It even kind of follows the same shape as Africa. Kind of cool, right? Then we have the Indo-Australian plate, and this is under Indonesia and Australia. So here's the Indo-Australian plate. If you can find Australia, you can find the Indo-Australian plate. Next, we have the Antarctic plate. So this plate is all the way down to the south part of the world. And again, we can't have a round map like the Earth on a flat piece of paper, so that's why this just looks kind of like rectangular. But if we were looking at a globe of Earth, it would be down at the bottom, the whole round chunk at the bottom. Okay, so those are the 7 major plates. We're going to learn more about these plates in the days to come. So the cool thing about plate tectonics is that these plates are always like moving around just a little bit at a time, maybe a centimeter or 2 per year. So, if you're just sitting there staring at it, you're probably not going to see it happen. But there's different ways that they move against each other, and where they touch together is called a plate boundary. The plate boundary is the place where 2 different plates have contact, right? Kind of makes sense. So we've got 2 plates. Where they touch is a plate boundary. Okay, so we're going to talk about these 3 different ways that the plate boundaries rub against each other. So a divergent boundary, they actually don't rub together at all. They move away from each other. So a divergent boundary, the boundary between 2 plates moving away from each other. So this is going to be super duper important. The way these plates move is kind of why we're doing this. So keep in mind, divergent, they're moving away. The next type of plate boundary we're going to talk about is a transform boundary. I think they're kind of cool, a little dangerous all at the same time. So a transform boundary is when 2 plates slide past each other. So I want you to take your hands and kind of slide them past each other. This is what happens with a transform boundary. We have our own transform boundary here in the United States. It's over on the west coast there where Canada kind of goes down into Mexico there. That's called the San Andreas Fault. And you remember our cootie catchers? We talked about a fault. This is a fault. It is a break between the plates. Okay, so 2 boundaries are sliding past each other. We might see some earthquakes happen at a transform boundary. Pretty neat, right? Next, we have a convergent boundary. And a convergent boundary is the boundary between 2 plates that are moving towards each other. Okay, so this can happen 3 different ways because of Earth's crust. You know, we have the 2 different types of crust for Earth's crust. We have continental crust, which is the type that we walk around on. We look out our window right now and we can see some continental crust. Okay, well, the other type of crust that we have is oceanic crust, and that's the crust that we find underneath the ocean. Well, we have convergent boundaries in places where oceanic crust and continental crust are coming together. So that's a different kind of thing, right? Then say in the next picture down, so this is oceanic crust bumping into continental crust. They're moving towards each other, and the oceanic crust is going to go under. Well, the next type we might see is oceanic crust moving towards more oceanic crust. Well, we probably wouldn't see anything happen there because that happens all under the ocean. But stuff does happen, and it's kind of neat. We're going to talk about that in the days to come. The next type of convergent boundary we might see is when we have 2 continental crusts moving towards each other. So here, boom, they're moving towards each other. We get some big mountain ranges when 2 continental crusts have a convergent boundary. A good example of that right there would be the Himalayas. You ever heard of the Himalayan mountains? If not, never fear. We're going to talk more about that in the days to come. So Alfred Wenger is the scientist who established the theory of plate tectonics, continental drift, and Pangea. So the theory of plate tectonics, I think we're going to talk about in just a minute, along with continental drift and Pangea. This is the guy right here behind it all. He's a pretty amazing fella. Here we go with plate tectonic theory. This is what Alfred Wenger came up with. He said the theory that the lithosphere, which is the crust in the uppermost mantle, is divided into tectonic plates that slowly move on top of the asthenosphere. Okay, so that's all that means. The plate tectonic theory, the theory that the lithosphere is divided into tectonic plates that move slowly on top of the asthenosphere. Here is the continental drift idea, okay? This is a theory that the continents were once connected but have drifted apart. There's a lot of evidence that the continental drift theory is actually a thing because our different continents, if we were to just cut out pictures of them, we could stick them together and it would almost be like a puzzle. They don't fit exactly perfect because of like the weathering and erosion and things like that of the edges of the continent, but they're close enough that we could definitely see how continental drift was a thing. So this is the idea, this Pangea. We think the Earth may have looked something like this right here before the plates started moving around and separating. Pangea is a supercontinent that existed a long, long time ago.